everyone. I'm Vidhi Thakrar.
I'm Sowmya Viswanathan.
Welcome to the Transition to Modular Architecture session, where we are going to share our journey from monolith to multi-module architecture. So let's see what we are going to cover in this session. So we are going to start with understanding the pain points which we have seen of the monolith architecture, then the objective which we have set ourselves for modular architecture. Then we'll go deep inside that how we have broken the whole application into multi-module, and we'll talk about the three-layer modularized architecture. And after that, we'll cover the very important aspect of the modularization, that at the end, it is a single application, then how the multiple modules are going to interact with each other. After that, we'll talk about how we have approached the modular architecture, given that there is a parallel development going on to deliver the new features, then how did we support this architecture evolution? And at last, we'll talk about how the modular architecture has impacted our project and our team. So let's begin. So before going to the pain points of the monolith architecture, let me share our story. So we have started the project for one of our client where there was a small application and then they wanted us to build features on top of that. So then we started like a team of 5-6 developers who started working on building the new features on this application. And everything was working fine. It was quite smooth. We were able to deliver the features successfully. But then over the period of time, as the application grows, where actually we had to support multiple features in the application, and at the same time, our team size has also grown from 5 to 6 developers working on the application to 25 to 30 people working on the same application, which has the monolith architecture. So that's where actually we started seeing the problems in the monolith architecture. So now let's go through the pain points which we have seen in the monolith architecture. So first one was the lack of separation of concern. Now, given that the whole application code base was inside the single module, there was no clear-cut feature boundaries. Just for the purpose of minimal reusability, we have seen that we started introducing the feature dependencies, which was creating a problem to us. The second one was the longer feedback cycle. Whenever we used to make any change to our code base, our CI pipeline used to get triggered and used to run the whole unit test, integration test, functional test, and it was taking a lot of time to provide us the feedback. Even for the local development, whenever our developer is going to push any change, for that he has to run like the unit test on the local machine, and that was also taking a lot of time because whenever a developer is making changes, developer has to run all the unit tests because the code was so complex and it was not easy to figure out where the change may have broken the other things. Now, due to this, obviously we were not able to deliver the features faster. We were slow delivering the features to the market. And then from the developer's perspective, we were having very low confidence because if we are trying to fix one change, we do not know where it is going to break the other features. So that was like a pretty low confidence from the developer's perspective. Now, due to all these problems, we were not able to scale up the team. We were not able to introduce more people to the team where actually the people can work on the independent features in parallel. That was just not possible for the monolith architecture. So due to all these problems, we started thinking about we need to break our application and we need to break it to multiple modules. Now let's just talk about the objective which we have set for ourselves for the modular architecture. So our main goal for the modular architecture was that we want to develop features rapidly, reliably, and repeatedly. Now, if we have to talk about that in a more concrete terms, then what we are saying? So what we are saying is that we want to have faster development of new features, as well as we wanted to have simplified way of feature extension. We wanted to have refactoring. We wanted to have refactoring can become very easy. We also wanted that we have a simplified test strategy for the modules, as well as we wanted to have isolated and faster feedback of independent modules. We also wanted to speed up the build time. At the same time, we wanted to scale up our team. So that was the objective which we have set for ourselves for modular architecture. So now as we understand the pain points and as we know the objective which we have set for ourselves, let's just talk about the modularized architecture, that how can we now split the whole application into multiple modules. So as we have seen that our main problem was the scale. We were not able to scale the team. We were not able to even scale the project. It was quite obvious for us that, okay, we want to break the whole application feature wise, which means we want to have a feature specific modules so that we can have multiple sub teams which can own the independent features and can provide and can provide the features as well as take the full responsibility of that feature. So because that is our goal, we felt that it makes sense to break the whole application feature wise. So this is how our architecture look like. At the bottom, you can see that we have a library modules. On top of that, you can see that we have independent feature modules. And at the top, you can see that we have an app module. Okay. So here in terms of dependency, what we are saying is that app module can have a dependency on feature modules as well as on library modules. Feature modules can have dependency on the library modules. So that's how the dependency would look like. So now let's take a look at the definition of all this different kind of modules. So first one is the library module. So library module provide common capabilities needed by multiple features, okay, which are not coupled to a particular business functionality. Okay, so which means it is providing like a cross-cutting aspect to all the features. Now, if I have to give an example for this, for example, in the application, if we are building like a common UI components which we are using across the whole app, then we can have UI kit as a library module. The second one is the feature module. So feature module provides the cohesive, loosely coupled, domain-aware business functionality, which should be independently testable as a single unit. If I have to give example for the feature modules, let's say that we are building a flight ticket booking system or flight ticket booking application. In that case, if I have to think about the feature modules, the feature module would be something like my trips, where it is taking the responsibility of providing and managing the trips which user has booked. The second could be flight shopping, where we can search for the flights and we can shop for the flights. And the third one could be the booking of the flights, where we are just booking the flights by providing the payment information. So this could be like an example at a very high level for the flight ticket booking application. The third one is the container. As the name says, it contains all the library and feature modules. It serves as an entry point of the application and also acts as an orchestrator to orchestrate the feature module interaction. Now, the orchestrator part we are going to cover next, but in terms of container, the example for the Android application is going to be obviously an app module. All right. So now we have seen the architecture of the modularized architecture. Now let's just try to understand the inter-feature interaction, which is like a very important aspect of the modularization. So let's first talk about that in an application, what kind of feature interaction would generally be required. Okay. So to understand that, what we have done is we have created like a very small shopping application just to understand what kind of feature interaction would generally be required in any kind of an application. So let's first try to understand that small application. So here this is a shopping application where on the first screen we see multiple categories of the products. If we go inside one of the category, we can see the list of products which has the product name and price. When you click on one of the item, here we see some more detail of the product. Here we can see some description, as well as here we can see two buttons. One is buy now and the second is add to cart. When we click on buy now, it is actually taking us to the purchase flow. And here we can add the payment information and we can buy that product. If we click on add to cart, then actually it is just adding the item to the cart. So here we can see that, okay, we have added the items in the cart, and from the cart as well, we can go and buy the products. So this is like a very simple flow of the shopping application. Now, if we think about that, okay, if we have to split this particular application into multiple feature modules, what kind of feature modules we will have? So here, if we take a look at the sample application at a very high level, the feature modules would be, one would be definitely like a product, which will manage all the product related functionality, like providing the product list as well as providing the product detail. The second one would be cart, which is like managing all the cart related functionality. And the third one would be the purchase, which is taking care of purchasing the product. So this is like at a very high level, we can think of these three feature modules. Now, let's just see that what kind of interaction would be required between these features. So if we have to talk about the product module, from the product, we are interacting with two different features. One is the buy, one is the purchase, which we are interacting with by clicking on the buy now. And here actually, by clicking on the buy now, we are just starting a new flow in the purchase module. And the another one is add to cart. When we are clicking on the add to cart, we are actually not navigating to the cart feature, but we just want to do, like we just want to perform some kind of an operation on the cart feature. So these are like a two very broad level categories of the feature interaction which would be there in any application. So as we have seen in the application, there are two kind of feature interaction which we would require. One is where we want to navigate to another feature, and the second one is where we want to perform an operation on another feature. Now let's just go through this one by one and try to see what kind of approaches we would apply to solve this problem. We will compare those approaches as well as we'll talk about what approach we have taken in the past when we have applied the modularization. So let's go through the first approach, which is navigate to another feature. So here, as you see on the screen, that from the product detail, we are starting the purchase flow. So let's talk about the first approach. So very first approach which come to our mind is that, okay, Android does provide the support of implicit intent, where we do not have to provide any direct dependencies on the activity, but we can still navigate to another activity. So we can just go ahead and use this approach, and we do not need to do anything on ourselves, because Android's little bit functionality would support that. So if we have to go ahead with this approach, how is it going to look like? So from the product module, what we will have is in the product detail activity, whenever we are clicking on the buy now, we just need to create an intent, and we need to pass the action name. The similar action name has to be there on the purchase activity. And then we are just passing some information, like in this particular case, we need to pass the product name and product price. And then we are just starting the activity with this intent. How it is going to look like from the purchase module perspective. Inside the purchase module, we will have a purchase activity. We are just taking this information from the intent, which is product name and product price, and we are just displaying it on the purchase screen. Let's just take a look at the pros and cons of this particular approach. So the good part of this approach is that we are using Android's inbuilt abstractions, and we do not have to create any other abstractions on our side, or even do not have to maintain anything on our side. The disadvantage of this approach is it does not provide us the compile time safety, as the intent is like a generic structure where we are just setting a key value. It will not give us any compile time safety. In this particular example for the product name, whenever we are setting the intent in the product detail activity, if instead of product name as a string, we set product name as an integer, it is not going to give us any problem when we are building the application. It will only create a problem when we are running the application, as well as when we are going to the purchase screen. There only it will create a problem. The another problem with this approach is that it is having indirect feature dependencies. So if you take a look at the code base, though we do not have direct dependency in terms of code, but still we are having some kind of indirect dependency in a way that we have to have the correct action name. The same action name has to be applied on the purchase activity, as well as the data which we are passing into the intent the structure of that data and the type of that data has to be the same where which is being expected on the purchase module. So now Sowmya will walk us through the another approach. Sowmya, over to you.
Yeah, thank you, Vidhi. Yeah. So we saw the first approach where we tried to use the generic abstraction given by Android. But the main pitfall that we see there is having no compile time safety. So now, if we think about one approach where we can guarantee the compile time safety, but still kind of have a generic abstraction, one thought that came to us was, what if all the feature modules had a provision to define their own navigations? So in our case, if product could define its navigation by giving a product object, and like from the cart screen, if cart could give a navigation to start the purchase by giving its own model, this would work, right? But to make this happen, what we have to do is all the navigations and all the domain models should be accessible by all the feature modules. So if we remember our architecture diagram, library module is one of the place which actually guarantees having all the which actually guarantees that all the features can access them. So what we can do is, in our common module, we can define a navigator. So here it is going to be a generic feature navigator which has a contract say start purchase. But if we look at the start purchase method, it takes in the product as the whole model. So it is not a generic data type like a map or a string or an integer. And the product is also moved away from the product module to the library module. So it can have all the details that are pertaining to the product. Now, to use this navigator within our product module, what we need to do is we need to inject this feature navigator. So we will come to the inject part in a bit. So, but when we use the feature navigator, so here, right, when we click on buy now, all we have to do is just start the purchase and provide the product. So from the initiator perspective, I have started the purchase by providing the product. But for the purchase to able to understand what is being sent, someone has to orchestrate this whole thing. And again, like if we go back to our architecture diagram, we saw that the app is an orchestrator for us. So in the app, we provide an implementation for our navigation called the feature router here, which takes in the product that is sent. It creates the intent and it sends it to the purchase activity. So here we can actually specify the component name, that is the purchase activity, because app can access all the feature modules. So now if we think about this approach and reflect upon it, the pros would be, again, the generalized abstraction is maintained because we have a single product model that is shared across all the features, and we have one place to actually specify our navigations. But if we look at the flip side, the library module is now overloaded. It actually knows about all the feature navigations. And the product as a model, when it is moved to a common module, it actually threatens the encapsulation part, because now if cart or purchase, they also have access to this product as a model, and they can add in the new fields, which is actually not needed for a product, but it may be needed for their modules. So it kind of threatens the encapsulation part of it, but still it will get us the job done to ensure compile time safety. Now, if we look at another approach, which actually, kind of balances out the encapsulation, we have something called as the contextual abstraction. Vidhi, if you would like to take over.
Yeah, thanks, Soumya. Okay, so now we'll talk about the contextual abstraction as another approach. So if we start thinking about the whole problem which we are trying to solve, what we are saying is that we have a product module. So here product is nothing but is a requester. Product is requesting that I want to start the purchase flow. And we have a purchase module which can say, okay, I can provide the service where any feature can start the purchase flow. So purchase is nothing but a provider. Now, if we want to just bridge between this, like because we have one module which is product, we have another module which is purchase, but both of them are quite independent. If we have to just provide that bridge, who can just take the request from product and use the purchase module to provide that to fulfill the request which product has asked. If we have to do that, which module can do this for us? So if you remember our modularized architecture where we have said that app is like a container which knows about all the modules, then app can act as a bridge between these two and also can act as an orchestrator, which is orchestrating the feature interaction. So here, what app can do is, app can say that, okay, I can fulfill the request for product by using the service provided by purchase, and hence, like from the product, user can navigate to the purchase feature. So that is how like this approach will try to solve this particular problem. Now we have talked about the navigation. Let's just think about the data part. So what purchase needs? Purchase needs some of the information of the product. Purchase does not need the whole product domain model. So then how can we solve that problem? So what we are saying is, from the purchase module itself, let purchase has its own purchase product domain model, which is nothing but the projection of the actual product domain model. In that case, we are not even adding any dependency. We are not even like putting all the domain specific models to a common library. So we are achieving the encapsulation as well. So if we have to then go ahead with this approach, let's just see that how the code is going to look like. So first we'll talk about the product module. So now remember that the product is requester. So in this particular case, what product would say, product will have one interface, which is saying product outward navigator. In that interface, there would be one ask, which is start purchase, where we need to pass context as well as we need to pass product, because product is available inside the product module. From the product detail activity, we will use this product outward navigator and we will say product outward navigator dot start purchase will pass the context as well as will pass the product. Now here you can see that product outward navigator is being injected, which means the implementation of product outward navigator is being injected, which we will see soon. Now, how would it look like from the purchase module perspective? So in the purchase, as we say that purchase is nothing but a service provider, in the purchase, we can have one abstraction, which is purchase inward navigator. And there it supports that, okay, start purchase as a function, which takes now purchase product. So what it is saying is that, okay, I'm providing you the service that any feature module can start the purchase flow if you provide me the context as well as if you provide me the purchase product. Here you can see the purchase product is nothing but the projection of the actual product model. And inside the start purchase, we will just create an intent and we will start the purchase activity. Because we are saying that the purchase module is going to be cohesive, which means all the functionality related to the purchase would be inside the purchase module, we can just directly access the purchase activity from the purchase module. Now let's see how app can connect these two modules and can act as an orchestrator. So app is going to implement the interface which product has exposed. So app is going to implement the purchase outward navigator interface. Let's call it product outward router. And then app inside the product outward router, we are also injecting the purchase inward navigator, which is nothing but the service provided by the purchase module. Inside the start purchase, what we are doing is we are just transforming product to the purchase product. And then by using the purchase inward navigator, we are just starting the purchase flow. So this is how app is going to act as an orchestrator. Now let's take a look at what are the pros and cons of this particular approach. So the advantages of this approach is all the features are independent. There is not even an indirect dependency. Second one is the compile time safety, because all the contracts are using the correct domain model which they have, and then it provides the compile time safety. We are not using any generic structure over here. It also has an encapsulation because the product domain model is only with the product module. Whatever purchase needs, purchase module will just expose that much, whatever is required by the purchase module. From the flip side, on the flip side, what we are saying is we may require multiple projections. So right now, as we have seen in the purchase module, we are having a projection of product. Tomorrow, if there is another module which also requires a projection of the product, then they also need to create more classes around the projection. So that is the flip side. Another problem in this approach is that app has become a very critical part here, because app is the one which is actually providing this bridge, which means it becomes very critical and we have to have the proper test coverage around that.
Yes.
All right, over to you, Sowmya.
Yes, Vidhi. Thank you. So now that we have seen the three approaches for now, right? So each approach came with its own pros and cons of it. So if we actually reflect and look at the three approaches, there is actually really not a, a correct approach that we can say, because it really depends on what our app needs and what our team needs, like in whatever approach we want to go forward. Like for example, few teams may be okay with having multiple projection across features, but for few team having a single model would suffice. So it actually depends on the team's need on which approach we go forward with. But in our use case, since we wanted all the feature teams to operate independently, and we wanted to have the contract set in place between the features and also ensure that the encapsulation is followed, we took the third approach, that is the contextual abstraction that we just spoke about, right? So this was the one that was picked by our team. But if we actually take this approach and try to apply to another kind of navigation that we saw in the app, that is where from the product screen, I actually try to add the product to a cart, where we did not move away from the product page, but we still needed to send some product related data to the cart screen. If we try to see if the contextual abstraction approach applies to this action as well, this is how the code would actually look like. So the product as a module will have a contract defined called as cart action here, because we want to add it to cart, and we say I want to add a single product to the cart. So it is able to define the contract with the domain model product. And in the activity, we actually inject the action, cart action, and we just invoke the method add to cart. Similarly, for the cart to be able to receive this action, it needs to provide a service to the other features. So it will provide a generic service called as add, but here it accepts a cart product, because like from the other screen also tomorrow, if you want to add items to the cart, it will just accept a cart product. And here again, the cart product is very local to the cart module, and it is a projection of the product, right? So it takes in the name, price, and quantity. Now, to orchestrate the whole thing, again, we take the advantage of the app module, where it provides an implementation for the cart action, and it does the transformation from product to cart product and delegates it to the cart service. Now, we see that the contextual abstraction can be applied to the actions as well as we had done it for the navigation. Now, maybe we will just quickly look at the code to see how the inject and all the wiring up has been done, right? So maybe first we will visit the product class, product detail activity. Here, similarly to what we saw in the slides, we have injected the cart action as well as the navigator. Those are the pure interfaces which just define the contract. And we use the Android injection to actually provide the implementation during runtime. So after that, we see the product detail activity is provided using the Dagger Android. So we have used Dagger Android to achieve this. And then when we go to the product module, yes, we see the product outward navigator as well as the cart action. They are provided using Dagger again. So it provides the implementation of product outward router and cart action executor. So if we go into one of the classes there, yeah, we see it provides the implementation for product outward navigator, and it also accepts the cart inward navigator. So the projection is done, like the product is converted to purchase product, and the purchase inward navigator is called upon here. Yes. So now that we have seen how the modularized architecture looks like, maybe we will just talk about how we approach this whole approach of modularizing our features. So the first thing that we had to do as a team, since it was a very big team, we had to identify a feature that could be taken out as a module. So the criteria set for us was, one, the existing feature development or the release cycle should not be hampered when we do this. And when we choose a feature, it should be either a new feature or a medium-sized feature that have had very little new requirements coming up. So once we identify our feature, what next we had to do was figure out the dependencies. So there are again two kind of dependencies. One would be the library dependencies and the other would be the feature dependencies. So now what we have to do is we have to start decoupling the code from the app module. So for the library dependencies, what we did was we started moving away all the library related dependencies to the library module. But the one thing to keep in mind here is like since the library module would be common to the whole app, we did not want to go all over the place and pick out all the library dependencies. We just focused on the logic or the code that would affect our features so that we get faster feedback and we are able to move faster. So once we started with this bottom-up approach of moving away the library modules for this feature, and we have a bare, feature module ready, we need to start taking out the dependencies for the feature. So when we do this, again, we have to ensure we take the bottom-up approach so that the existing code still runs even with the few classes being in the app module or few classes staying in the feature module. So to do that, we first move the models to the feature module. Then we go with the repository and the network API calls. Then we take the view models. And then at the last, we take the UI out of the app module to the feature module. So once we did it for a feature and we were confident, we took the same approach for a few other features. So at the end of doing it for a few of them, what we could see was our build time had reduced, significantly. We could see about build time reduction by 25 to 30%. And next, what we could see was since we wanted it to be sliced as per features, our feature teams specific to any feature could be developed. They could be formed and they could develop because the boundaries were set in, the contracts were all set in place. So all the feature teams were able to move faster. So we could see a time reduction of 20% there. And new teams could be easily formed. New smaller teams could be easily formed who are focused on a specific feature. So we could scale up the team by about 50%. So this was our story of how we approached modularizing our monolith app and what all approaches we actually deliberated and finalized when we took this approach. So this is all we had to share, and we have uploaded the sample app that we just showcased in the GitHub repo. So if you have any questions, we are ready to take them now. Thank you.
Yeah, so maybe we can get started. The first one is, can the feature modules be dependent on each other? Can library modules depend on each other? So library modules may depend on each other because that is something which we have also done in our project, where we had come up with a core as one of the module, which was having like a very core functionality, which may needed by like some of the library modules. So I think dependencies in the library modules are still fine, but the feature specific module dependencies, we would say don't do that. Otherwise, the whole purpose of the modularization would not be suffice. So try to not have dependency between the feature modules. Still, we have seen one of the case where, for example, if you are having even like a shopping app itself, and like in your use cases, it is like the whole product is going to be, and the product list and product detail, all of this are like used at multiple features, and like 80% of the product feature is being used across multiple features, then maybe we can think of so having like a very little dependency on the heart of the feature module, I would say. But try to avoid it as much as you can. That's what we can say. Where database model or data access is defined. Sowmya, do you want to answer that?
Yes. So for the database model or access rate, again, it depends on what approach we want to take. So in our approach of contextual abstraction, we ensured all the model remain very local to the feature modules. So in our case, the product as a model or all the database access was very local to the product module, and same for cart and purchase. But if we go with the first two approaches where we want to where we want to share the domain across all the modules, then they would have to reside in the library module. So it really depends on which of the approach the team finalizes on.
Did you use only one GitHub repo for all modules or have some separate modules? Yeah, so we are using single repo, multiple modules. We were also thinking of using the submodules, but like it is not too easy to go ahead with the submodule, and like, in terms of development, like we have to keep pulling the things from the submodules as well. So that's why we did not go ahead with that. We had gone ahead with single repo having multiple modules. Where can we find the slides? So I think after this, we will just put the slides up in the speaker block. So you can find it inside the speaker block section on the Talk app. How do you manage versioning and releasing the app? Are features versioned independently or do they share a version number? This is a very good question, I would say. So yeah, we had not yet gone that far, but I can definitely see that by having the feature specific modules, we can do that. So I think the one of the thing which we were thinking of, like, after doing this whole modularization, was that the features can be like a plug and play. And then feature can also have a different kind of a versions. And then while building the whole application, we can decide that, okay, for this particular feature, for example, for the cart, though there are two versions available, 2 and 3, for example, 2.0 and 3.0, but for this particular release, just like plug in the 2.0 version, and 3.0 is still like in progress kind of a version. But honestly speaking, we haven't tried that out. But that was something which was we were thinking about that. Now we can move to that direction as well. If I have some multiple flavor, on which module should I set as flavor? Only on app module or feature module? So this is also, like, I would say, a very good question. We were also having like a multiple flavors, and honestly speaking, there was like difference of opinion within a team. So one opinion was that only have it as an app module, but for all the feature specific modules, what we can have a default resources, right? Which could be there in the feature specific module, but app will have more flavors. So I think that is one of the approach which we have tried out in one of the project, and I think that has also worked pretty nice for us. The other approach which we had taken, because in that particular project we were mainly focusing on that I want to have independent feature, and like the feature should be cohesive, which means everything should be there inside that feature. There actually we were thinking of creating and using multiple flavors at the feature module level. But if you are using multiple flavors at the feature module, the only thing which we need to, so the good part is that it will give us like a feature independence, and the whole feature is like complete inside that module. We don't have to go anywhere to figure out, okay, now what is the flavor, how the flavor is being used or anything. So that is the advantage. But the other side of it, it's like while running the test and other things, it may take little more time in terms of giving us the feedback. But we have tried both the approaches. Okay, the next question is, should we have feature module for each screen? Sowmya, do you want to answer?
So each screen need not be a feature module. So in the case of our shopping app, we could see the product being listed as well as the product detail. So technically there are two different screens to list the product as well as the details, but they all fall under the same module, same feature module, like the product module. So it is better based on the business use case or the functionalities, we may have to group the feature modules and not go as per screen by screen.
Correct. Also, I think one very important point here to notice that whenever we are splitting the application, just make sure that we do not create a very small feature. Otherwise, it will also not give us the benefits what we are looking for. So I would suggest that start with the higher level features, and then if required, again break it into multiple features. But do not start with like a very small feature modules. Is this approach is good too for feature that need to be a play feature delivery? Because feature module depends on app, it will be hard to separate. Any advice to do navigation on feature module on play feature delivery? So actually I do not understand. Is this the play feature delivery is the dynamic feature delivery? Sorry, I'm not able to understand.
I'm also not able to get the questions.
Yeah, maybe I think we can talk about this question and we can have a conversation on the speaker block. And then maybe we can take that up. We need to understand more that what do we mean by the play feature delivery. Do you have one team to manage the library module? If so or not, how do you decide the code should be in library or not? Yeah. So Sowmya, do you want to answer? Yeah.
Yes. So, like in our approach, we did not go big bang on the library module. We started building the library module when we started, modularizing each feature. So, when we actually, like for the product, whatever library module is necessary, if we take them out, we try to apply it to the app as well. So, the library module gets built over a period of time and it is not tied to a single team. But I think all the feature teams should be cognizant of this fact. Yeah, Vidhi, do you want to add something there?
I no, I think this is correct, and I think the definition which we have seen for the library module, right, it should not be coupled to any particular business functionality. Something which is cross-cutting. Okay, so for example, there is something which is very common and being used across multiple features that should go down to the library module. That's the idea. Do you have sub feature? Okay, do you have okay that we have answered? How does your espresso testing setup and DI look like for testing? So this is also, I think, a very good question. I would say the espresso thing is like for each module we will have like a espresso test. So each module is managing their own test. In terms of DI, like for example, if I have to just give you an example for the product outward navigator, what we need to do is because in the product module we are just having an interface. While running the test for the product detail activity, we have to provide the mock implementation of that product outward navigator, and that is what we have done while testing the product detail activity using Espresso. How do you handle the string localization in modular architecture? I think this would be something similar as we have discussed for the flavors. Either we can have a string localization inside the module itself, or we can use it in the app, and then the feature specific modules may have the default local set and the default resources set. Why don't you create one more layer just for screen navigation? Did you face any difficulties on it or never tried? So, yes, I think the approach which we have talked about, I think the second approach where we may have a screen navigation as a generic feature, I would say. Even if we add it, like, for example, between library and feature, the important part to note here is not just the navigation. Maybe navigation would be easy to solve, but then the data passing is like a very big thing. That how are we going to pass the data? Because whenever we are navigating from one feature to another, we may have to pass some data. In that case, it will create a problem. Then we have to then like share the domain, put the domain model inside the common module as well. So that's why we did not go ahead with that approach. I think we are overshoot. So thank you so much, everyone. We can have further conversations on the speaker block. Thank you.
Thank you.